Hello, this is Mr. Huff, and I want to go through 10 big ideas for flowcharts. This is for programming design. The first thing I want to point out is that a flowchart is a symbolic representation of a logical flow, and on this slide you can see we've got a lovely example of a flowchart that you can kind of digest. This is really crucial in designing software in the context of a large team, so that you can have a clear design of how the program is supposed to work, and then you can divide that up into processes so that you could have someone working on checking the dog bowl, someone working on the process of pouring the bowls, someone working on this logic about how to check to see if it's empty, and that sort of thing. So I don't really plan to use this for our main method of software design, but you need to know about it because it is something that's important in the world of computer science. Next thing, this page just shows us, this is a second fact, that shapes have meanings. These aren't just random shapes thrown around to make them look cool. Each one has a symbolic meaning, so when you're looking at a flowchart without reading the text inside there, you know what's happening. If it's making a decision, or if it's displaying something to the user, or is it expecting some sort of input or producing an output, or is it just the beginning and ending of the program. The arrows are really important because they show the direction of flow. Okay, so let's look at the different symbols. So third big fact, you're going to start with a symbol like this and end with a symbol like this. This gives your program flow a clear beginning and a clear end, so it's important to have that. The rectangle is a process. This is like a verb in a sentence. It's when it does something. It's going to do something with some input. It's going to produce some sort of output. So this is where in your flow you're doing something. There's an action taking place here. The parallelogram is called the data block. It's an input or an output. So this is where it asks you to put in your birthday, or if it checks a temperature to see what temperature from a sensor. It can also be where an output from a program saying, okay, this is the length of the hypotenuse. This is the result of your trig function. So whatever you're doing there. So this symbol tells you you're either collecting something or you're producing an output that can be acted on. The rhombus here, or sometimes it will be called the diamond, it's either a yes, it's like a yes or no. You're making a decision and it's only going to be this or that. It's always just two outputs. So you're going to say, is this greater than 10? And if it's true, then you do one thing, and if it's false, you do something else. Sometimes in programs that are complex where you're checking multiple things, you have to have a nest of these that are all kind of linked together. You check this, and if that's true, then you check another condition, and if that's true, you check a third condition, and so on and so forth. So here are arrows. They indicate the flow of your program. If you're, kind of the logical process starting at one place and going to the other. An important thing to take note of is if you are going into a process, you can have multiple arrows going into a process, but whenever it produces an output, it should only be one. It gets really difficult to control your program if you have processes producing multiple outputs. Okay, so input can be multiple, outputs should be single. Eighth big idea is an example flowchart. So we're going to go down to where it actually has the completed flowchart, and we'll go through it. So if we have the start block, and then we have an input starting with the number 1, and then it has a little process here where it says a number, so it would say 1, and then it's going to take the number 1 and add 2 to it, check to see if it's greater than 9. If it's not greater than 9, it's going to loop back up here to the process and say the number 3, and then add 2 to that and check again, is 5 greater than 9? If it's not, then it's going to loop around until it reaches the number 9, and then after 9 it's going to say, is this greater than 9? Then if that's true, it's going to end the program. This is a simple flow of or an example of just a counting segment. That's what it looks like. I want you to notice we've got some really handy flowchart tools. If you go to Google Slides, you can choose shape, and the shape button, and if you choose shapes under that, If you skip the little boxes at the top and go skip over the ones in the middle, this very last row, you can see all of the shapes we've just talked about. We have the start, we have process. This is this little rounded rectangle. This is an alternate process. We have decision, we have input output. So everything you need to make a flowchart is here. If you hover over these, it will give you an explanation of each one. Again, we're just touching on this. You need to know the basics, and that's it. We're going to use pseudocode for most of what we do in class. So what I would like you to do is, in your notebook, think about all the steps you would need to have to get a glass and get a container of milk and pour a glass of milk and put it all back. So make a flowchart for me for how to pour a glass of milk. Let's see if you can think like a computer.